To help you get ready for your quarter four exam, I'm going to go over some problems. There might be examples of things you've seen this quarter and things you might end up seeing on your exam. Now, this problem might look familiar. Chances are you did see it on your quiz. So I'm going to walk you through it so you get an idea of how you'd solve something like this. Now, immediately what most people do is they run to this question mark and they say, I can't do this. There's not enough information. Well, here's the thing. You don't have enough information to solve that yet. There's a lot you still don't know, and you're going to have to learn that in order to get to that point. Because we're looking here, notice we don't know what this angle is. We don't know that angle. We know it's 90 degrees, but we don't know this one, or even this one. So what's a good idea to do is solve the things you don't know first, and then worry about the big question. Now, if I go over to here, I notice that we have 115 and our unknown angle. They lie on a straight line. So I can do 180 minus 115, and I get 65. So that gives me this angle. And now, what do you know? I've got two angles here, and I'm trying to solve this third angle. I've got two interior angles of a triangle. I know that the interior angles of a triangle have to add up to 180 degrees. So to get here, I can do 85 plus 65. So give me 150. Take that away from 180, and I get 30 degrees. So if I add 65, 85, and 30, I'm going to get 180 degrees. So now I'm getting somewhere. I'm making my way over. Now over here, this trips some people up a little bit. I've got 30 here. I know this is 90 degrees. How do I find this other one? Well, just because it's three angles here doesn't mean that's still not a straight line. I still have a straight line made up of these three angles, which means straight line, all the angles on a straight line have to add up to 180. So if I do 90 plus 30, I get 120. Take that away from 180, and I get 60 degrees. Now there are a couple of ways I can get to this next point here. What I'm going to do is I notice that, again, got 155 up here and an unknown angle. These two angles, again on a straight line, have to add up to 180 degrees. 180 minus 155, and I get 25 degrees. So I get 25 degrees here. And guess what? I can solve this question mark now. I don't even need this third angle here, because the exterior angle theorem tells me that if I add up two interior angles that are not adjacent to this exterior angle, I'll get that exterior angle. So if I do 60 plus 25, I get 85 degrees, and I've solved for that question mark. As you can see, this is a bit of a process. You can't just jump right in. You gotta work your way, solve one piece at a time. And of course, what I saw other people do too is they add 60 and 25, subtracted it from 180, then they got that this was 95, then they did 95 minus 180, and they got 85 degrees. So there are a number of ways you can get here. But the key is you just gotta break it away piece by piece. Much like this next example here. Again, we got 155. Don't know this angle, but I do know they're on a straight line. 155 minus 180. I know it's 25 degrees because I just did it. And again, 25, 60. I have an exterior angle. I can add the two non-adjacent interior angles here. 60 plus 25, and I get 85 degrees. So again, the key is you can't just jump straight into the one that's being asked for. You're going to have to fill in some blanks to get there. All right, now for C. This one gives people some trouble. You have to use this equation to answer the questions below. I think I might have even put together a video doing this one already, but nonetheless, I'm going to do it anyway. All right, now I have to write an equation for a line that's parallel and passes through a given point. The equation I have here is not in slope-intercept form. I do not have a slope here. I have to put it in the slope-intercept form first. So I'm going to do that. In order to do that, I have to get y all alone. So I'm going to subtract 5x from each side. And I'm going to have to do some shrinking here, but that's okay. I get negative 10y equals negative 5x minus 30. Next step, I have to divide each term by negative 10. I can't just leave it as negative 10y equals negative 5x minus 30. A lot of people are doing this. Can't do that. You need to get in the slope-intercept form. This will now simplify as y equals 1/2 x plus 3. I now have a slope. That is all I need from this equation. I do not want the y-intercept because that's not going to be the same for my new equation here. Again, parallel lines, they have the same slope but different y-intercepts. So I want it to be in this form. I do have m. I have 1/2. Because again, same slope. But I don't know anything else here. Now, I can't just solve b. I can't just plug in something for b. I don't have that. But I do have an x and a y value here, which I can plug in. And I'm going to do that. Once I do that, I think in one of my other videos I show this, but I'm just going to, I'm just going to jump to the end here. Typically, you'd want to show your steps, but you should be getting negative 30 equals b. And that's through some basic algebra. And now I can write the equation for this line that is parallel and passes through this given point. Y equals 1/2 x minus 30. And again, the trick here is you want to make sure that you get the equation in the slope-intercept form, and then you can plug in your x and y values to solve for b. I'm going to do the same thing down here. I can use the same equation, but now I want something perpendicular. For perpendicular, it means I need the slope that's the opposite reciprocal. Opposite reciprocal of 1/2. It's not just 2. A lot of people just said 2. It's got to be negative 2. Remember, you want the opposite reciprocal. Well, negative 2x plus b. All right, so now I just got to plug in my values again. Negative 48, negative 2 times negative 36 plus b. Again, just doing some basic math here. 72 plus b. Subtract that on each side. And I get negative 120 equals b. That's why you don't want to try and solve this by just graphing it, because this would be crazy if you're trying to put this on a coordinate plane. So just plug in my slope, negative 2. And I plug in b, which I just solved for. I think I did another video, or at least a couple of videos doing similar problems to these, but nonetheless, I wanted to walk you through these. You will end up seeing problems like this on your exams. So again, for the triangles, just make sure you're working one step at a time. For writing equations for parallel and perpendicular lines, make sure they're in slope-intercept form. Use the slope, and then use your x and y values to solve for b. Good luck.